talking about today is 2D Geometry, Lesson 5. It's scale drawings in area. The homework that goes with this is page 12 to 15 in your homework packet. All right, I want you to do this for a warm-up. Go ahead and pause this now, do it, and then turn it back on. All right, draw a right isosceles triangle. Well, a right triangle has a right angle. So when you draw this, first thing you need to do is put a right angle in. Now you can either draw the right angle with a box or put 90 degrees in. Right isosceles. Isosceles means two sides are congruent. So I'm going to put a hash here and here. 2 here. So this is a right isosceles. Now, when you do this, the two legs, which are the sides of the right angles, have to be the two that are equal. If we wanted to go further, these would both be 45 degrees, because if it's got two equal sides, it also has two equal angles. So they would be 45 because they add up to 180. Equilateral triangle. So when I draw this, equilateral means 3 equal sides. If it's got 3 equal sides, it also has 3 equal angles. So they each be 60. So you can either mark it with the hashes, or you could write 10 inches, 10 inches, 10 inches. Same thing here. I could have written 7 inches, 7 inches, and made that something else. An acute scalene. All right, acute has 3 acute angles. Now, you cannot just draw a triangle and make them look acute. I need to label them. Well, we know 60, 60, 60 is 180, so I'm going to cheat. I'm going to make this 60, 61, and 59. I'm going to all acute angles. So 3 acute angles. Scalene means 3 different sides. So 1, 2, 3. 3 different sides, 3 acute angles, and they're all different. Obtuse isosceles. All right, so obtuse isosceles. I'm going to make this 100. I'm picking an angle that is more than 90, and I need to label it. Isosceles means it has 2 equal sides. Well, if it's got 2 equal sides, it's also going to have 2 equal angles. So if this is 100, both these two together have to be 80. So this is going to be 40 and 40. And make sure your equal angles are across from your equal sides. Obtuse equilateral. Okay, obtuse equilateral means it needs to have an obtuse angle. But equilateral means they have to be the same. So it is not possible. Because equilateral will have 60, 60, 60, and that's it. There's no such thing as an obtuse equilateral. All right. Find the missing angles. Pause and do these two. All right. This angle is 30. We've got 2 equal sides. So 30 is across from that side. This side is also going to be 30. 30 plus 30 is 60. So this one needs to be 120. Because remember, all 3 angles in a triangle add up to 180. All right, here we go. This is an equilateral triangle. All 3 equal sides, which means 3 equal angles. 60, 60, 60. That's the only way they can be equal. Okay, pause and do these two. I'm going to find this angle right here, x. So x plus 30 plus 100 equals 180. So x plus 130 equals 180. Subtract 130. X is 50 degrees. Here we go. This is 90. These two are equal, so it is an isosceles triangle. So the angles opposite them also have to be equal, and note the two together have to be 90. So this will be 45 and 45. All right, we are on page 12 in your note packet. Mr. Gautier has asked you to calculate the actual area of this half court that he wants to build next to the parking lot based off the scale drawing that he has from the architect. Based on the drawing, what is the actual area of the half court? Our scale drawing is 1 inch is 15 feet. 1 inch is 15 feet. So our scale, 1 inch is 15 feet. Now, the one thing that you must understand. Some kids like to find the area of this. This is in inches. and then try to convert it. You cannot do that. You need to convert the length and the width into the appropriate unit first. So we need to change these inches into feet. So I'm going to set up a proportion. You may be able to just do this mentally, but our proportion, I'm going to do inches over feet. So our scale is 1 inch is 15 feet. I want to know 2 inches down here is x feet. Cross multiply, x is 30 feet. So I'm going to write on this 30 feet. I like to label my diagram. It makes things easier to find the area. This one, again, I'm going to do inches over feet. So my scale is 1 inch is 15 feet. We want to know how many feet x is 1 2/3. If I cross multiply, I get x is 25 feet. So this is 25 feet. And again, I like to put the actual dimensions on the diagram. So it says, find the actual area. So our area is going to be length times width. And I'm going to use the actual distances, which is 30 times 25 is 750. And again, I'm going to label it square feet. All right. It says, if it costs $2.75 per square foot of paved macadam, and Mr. Galtier's budget is $2,000, can we complete this project? All right, let's set up a proportion again. We're going to get square feet, set up a proportion to do this. So we are comparing square feet to cost. So it costs $2.75 per square foot. Actually, you know what? I'm going to write this the other way. I'm going to do cost per square feet. So it's $2.75 for 1 square foot. We want to know x for 750 square feet. So if I cross multiply, I will get x is $20,062 or $2,062.50. So do we have enough? No, not enough. Because the budget is $2,000. Okay, a scale drawing is used when an object is too large or too small. Let's look at example 1. Josh made this scale drawing of a rectangular flag. He wants to produce a second scale drawing of this flag, but he wants it to be larger than this one. If he uses a scale factor of 2, what will the lengths of the new drawings be? So, a scale factor of 2 basically means you're doubling it. So, this side, 1, 2, 3, 4, is 4. If we double it, it's going to be 8. This side is 1, 2, 3 units. 3 times 2 is 6. So, if I make my new drawing, I'm going to go 8 across, 1, 2, 3, 4, and 6 up. There's my new drawing, 8 by 6. This was 4 by 3. Scale factor of 2 means we are basically doubling. It's the constant of proportionality. Scale drawings include a scale. The scale compares the length of the scale drawing to the length of an actual object and can be written as a ratio. Scale units do not have to be the same. So we can do centimeters to meters or inches to feet or whatever. This drawing shows the floor plan of an exhibit in a museum. What is the perimeter of the actual? The actual, well, look down here. 1 centimeter is 3 meters. These are all given to us in centimeters. So, if I do a proportion, pretend you don't know if you're going to multiply or divide. Let's set up a proportion. Centimeters to meters. So, 1 to 3 is the same as, let's do this one. It's centimeters, so 13 to x. Cross multiply, I'll have x is 39. Basically, I'm going to need to multiply every one of these by 3. And I figured that out by setting up our proportion. So, this is going to be 39 meters. If I multiply this by 3, I get 25.8 meters. If I multiply this by 3, I get 39 all the actuals. So 24.3 plus 39 plus 30.9 plus 25.8 plus 39. The perimeter of the actual is 159 meters. Again, convert before you find the area, or the perimeter, the actual. Okay, skip ahead in your notes to example 5. It says, a rectangular blueprint is 3 4/5 inches wide and 8 1/2 inches long. Patty makes a scale drawing of the blueprint using a scale factor of 5 halves. What is the perimeter? Well, the scale factor of 5 halves is basically the constant of proportionality. So all you're going to do is multiply. So our new length is going to be 8 2/5 times our scale factor of 5 halves. When you multiply that, you get 21, and it is going to be still in inches. Our new width, 3 4/5 times our scale factor of 5 halves. Scale factor is constant of proportionality. You're going to multiply, and you get 9 1/2. Once you get our new dimensions, you are going to find your area and perimeter using the new dimensions. So our perimeter is going to be 2 times the length plus 2 times the width. So 2 times 21 plus 2 times 9 1/2 gives you 61, and we're labeling that inches because it's perimeter, it's linear. Or this is perimeter. Area is length times width. So it'll be 21 times 9 1/2 gives you 199 and 1/2